Okay, so we're graphing mass and acceleration data. Let's take a look at that. I did also basics of graphing in sheets in the previous video, so I'm going to gloss over some of that here. Click the little graph button. I get a scatter plot, which is what I want. The labels are already in there. So now I'm going to go to Customize and go to Series. I want to add a trend line to this to see if does the data fit what we think it will. By default, it goes to a linear fit, and it's clearly not linear. It's not a linear fit, so we don't want a linear fit. What we're going to do is we know that Newton's second law, which I have over here in this, move over. Newton's second law is acceleration is directly proportional to the force, inversely proportional to the mass. So as the mass goes up, the acceleration goes down, which kind of is what the trend does here, but it's an inverse relationship, right? So we could say that it's proportional to 1 over the mass, and that's a power series. We're taking it to a power of -1. So if instead of a linear trend line, I want to do instead of linear, power series. Bingo, and that lines up. Nice. If I'm not sure, I can show the r squared here and label it with the equation that we have. And I can check the other ones. If I go to polynomial, for example, r squared is 0.97. If I go to linear, it's 0.831. The lower the number, the less of a fit it is to that model of the data. If I go to logarithmic, 0.95. But if I go to power series, 0.999. Great. That is the best fit for this data. So that's what we want. That's how you would check. All right, I have the equation. I have the r squared value. I'm going to leave those in there and close it. So that is one way to do this. There is another way. If you want to use a linear trend line, let's plot things that would be linear. Acceleration is proportional to 1 over the mass, right? So let's delete this. I'm going to insert a column here, right-click, insert one left. I'm going to make this column 1 divided by the mass, or 1 over kilograms, or the units. Basically, I'm going to start with an equal sign, go to the left, take that cell, take 1, divide by that cell, divide by the mass, and I get 4. So 1 over 0.25 is 4, 1 over the mass. And it automatically does a suggested autofill, and why, yes, I do want to do the same thing for all of those. So boom, there's all my masses. If I want to clean this up and not have all of the digits, that's what these two things do. They can decrease the number of digits and maybe keep it to the same number that are here. Excellent. So I'm going to graph 1 over the mass by the acceleration and see what that looks like. Bam, that looks nice and linear. Let's check the trend line, series, trend line, linear, excellent. So that looks much better. Let's add the equation, show the r squared. And here we have, it's a linear equation, so mx plus b being the y-intercept. If you see the e to the -3, that's basically times 10 to the -3rd, so that's 0.005, very close to 0. And the r squared value is pretty close, so this fits a linear relationship when we look at acceleration versus 1 over the mass. So you could show the relationship either way. You can look at it both ways and have both graphs on here, but that's what we're using to do it. So again, under customize, and you're customizing the series, and you're going down to trend line and using a linear trend line if you're using 1 over the mass, or a power series if you're using just the actual raw data. Either way, check your r squared value and turn on that equation so we can see what equation sets up as. And added bonus, can you figure out what that number out front actually represents in this case? I'll leave that as a challenge to go further with. So I think that's all the things. Good luck. You got this.